So the more you do it, the hotter it gets.
Welcome back to our conversation with Ted Porter, talking about suspension. Many adventure riders don't realize that when they're riding off-road, their rear suspension gets very, very high.
We are converting kinetic energy into heat, and that's why when we leave the pavement, we have more heat, and we have to be able to handle it. There are certain shocks that don't handle as well as other shocks do.
Heat is generated anytime fluid moves from a high pressure area to a low pressure area without doing work.
When the shock compresses, it pushes the oil through these little holes and slots in the piston, and on the other side, this stack of shims is attempting to not allow that oil to flow through the piston. The more shims we have, the more resistance that we have.
A shim stack is made of these small washers made of spring steel. All they are is a stack of those washers that create a certain amount of resistance inside the suspension to control flow. Inside, there's these different ports. These washers block the second tier of ports, and when there's enough pressure, that shim stack will flex and open up oil flow.
And then on the rebound stroke, now the oil has moved its way over to this side. And on the rebound stroke, we're simply doing the exact same thing in the other direction.
To adjust the flow, shocks have a rebound damping adjustment.
We can put a bypass in this piston to allow a certain amount of oil to make it through the piston to the other side without going through the valving. And that's what your rebound damping adjuster does. Sometimes they're a screw, sometimes they're a knob, but all it does is there is a rod going up through the center of this shaft, and it's pushing a needle in and out of a needle valve inside this assembly. And when we open it, it's just like allowing water to flow through your kitchen sink, okay? You're just opening the valve, and the fluid is allowed to bypass these shims.
When we're riding off-road, our shocks get really hot. That means the oil gets really hot. And when the oil gets hot, we get fade. Fade means the bike's gonna get really squishy and less in control because the oil is so thin, it's not being restricted properly going through all of that damping valving.
We also have thermal expansion. So as things heat up, they start to grow, and we can start losing the seal between the piston band and the cylinder. So oil starts escaping around the side. We also have a thing called cavitation of the oil, where the oil actually starts to gas. There's this, I don't want to get out in the weeds too far, but there's this thing called vapor pressure, and as the vapor pressure drops, the more the oil can cavitate, and it'll literally foam. And so now you're pushing foam through the valving. So it's really important to keep an eye on shock temperatures. I've always said I wish that the display had a rear shock temperature gauge so that you knew that if you knew your engine was overheating, you wouldn't keep going, you'd give it a break.
The front shock doesn't generate near as much heat as the rear shock. It's not carrying the load of the rider, it's not carrying the load of all your luggage. Also, when you're getting on the gas to lighten up that front end starts skimming across things, but the back end is still just pounding through all of those ruts and rocks.
The original suspension on this bike had a 140 Newton meter rear shock and only a 50 Newton meter on the front. So that gives you an idea of where all the load is, where all that heat's being generated and so on. We don't see front shocks overheating typically, but the rear, it's a real issue.
Make sure you have the right suspension before you head out on a big trip.
People understand they need the right tires, they need the right protection and so forth. They also need the right suspension. And the original equipment stuff is really not designed for that kind of use for very long. You also want to make sure that you buy suspension that suits the application. I understand we all want to save money. We don't want to spend more than we have to spend. But there is a point where, a customer calls and says, I'm doing the Intercontinental Divide Tour, then I'm going to Baja, and then I'm going to do a couple BDRs. What's the cheapest shock you have? Sorry, that's not going to work. You're going to have to save up money and buy the right suspension.
There's three types of shocks: emulsion shocks, internal floating piston shocks, and reservoir shocks.
The first type of shock at the lower end of the price spectrum is an emulsion design, and they work great on the street. Not recommended for off-road riding, but for street use, low cost, They dampen really well and they work really well. And basically they're inexpensive to build because you start with a shock cylinder and your piston rod assembly with the piston on it. And basically this cylinder just gets filled halfway with oil, and then the assembly goes together and it gets a shot of nitrogen. So it's a very simple but very effective way to build a shock absorber. And for street use, they're awesome.
But not so much for off-road.
When the oil gets warm, which happens when you leave the pavement, the shock starts cycling a lot. When it's got gas molecules in it, it can't really shed the heat as well into the cylinder wall. And then you've got a steel cylinder, and that doesn't shed the heat so well either. So when these are taken off-road, they can get quite hot. And then when they start to foam, it's called cavitation. You get gas bubbles and foaming, and now you're pushing foaming through the valving, and you end up with fade.
Next up, internal floating piston shocks, or IFPs.
For moderate off-road riding, an internal floating piston design aluminum shock will get the job done. There's an additional part in here that separates the oil from the gas. So the benefit there is that the oil is just oil. There's no gas molecules in it. It can shed its heat better, which lowers your cavitation, very important part. No foaming, no bubbling in the oil. And then usually another type of material will be used. In this case, it's a 6082 aluminum. It's an extrusion. It's very strong. It's been heat treated and it's been hard anodized. So we really consider an IFP design to be the entry point for off-road riding.
For adventure riding off-road, we really should be considering reservoir shocks.
If they were all the same price, people would just buy reservoirs because it's a superior product. The nitrogen is now in the reservoir. We don't need to leave room for it inside the shock. So this shock's 100% full of oil. So way better heat management. Obviously much more advanced compression circuit. So for best performance, best heat management, most reliability for off-road, for true adventure bike riding, the Reservoir is definitely the way to go.
All right, Ted, I want the absolute best shock I can get. I want all the features. What's the best?
Once you get to the Reservoir level, you've pretty much reached the best, but there is one more feature that some manufacturers use, and that is the PDS, or the anti-bottoming valve. So what this is a second piston. We already spoke earlier about the piston that actually does the valving, but there's an additional piston on models that have PDS. The PDS valve, which is an anti-bottoming valve, does nothing a lot of the time because, as you can see, it does not seal. Like the main valving piston seals. The oil can't escape around the side of the piston. And what happens is that secondary valve adds compression valving towards the end of the stroke. And what it does is, instead of having that hard bottom out, it slows the compression event down at the very last bit of travel. And it has a different feel. It really does. Rather than hitting the bumper and bouncing off the bumper, this increase in compression valving right at the very end slows that whole event down.
With reservoir shocks, you're far more likely to get the full range of adjustability to truly tune that shock to be just ideal for your riding situation.
This is a much more sophisticated compression circuit. Now, instead of just relying on a stack of shims that are flexing as the oil passes through them, we now can treat the oil on the compression stroke based on its velocity. So when you have a low speed compression event, which is really more about chassis movement, you can control that with this needle valve. So you have your rebound adjuster, which is a needle valve. Now you have the low speed compression, which is a needle valve. And then we have a high-speed circuit that really kind of acts like a pressure relief valve. Essentially, when you hit something that causes a very rapid compression event, very high shaft velocity, that oil pressure that builds up in the head overcomes a little spring-loaded valve, a little spring, and pushes it open. And now that oil pressure can bleed off into the reservoir at a higher rate of speed. And that is also adjustable. You're essentially adjusting the spring tension. So the low speed is a needle valve, the high speed is adjusting the spring tension on that pressure relief valve.
What if the only thing I'm going to do is go ride down a gravel road and go out camping, and there's a little bit of washboard here and there?
People always say, well, I don't do anything aggressive. I'm just on dirt roads. Well, if your shock could talk to you on those dirt roads, it would say, man, you're killing me down here. So this concept that I'm not doing anything aggressive, well, that's because the shock's doing its job.
What can an adventure rider do to work around the fact that they don't have a really good shock? Can they stop and let it cool down? Can they have less load on the bike?
Okay, well, I can sell you a spring. So we can improve your load capacity that way. But in terms of being able to handle the use of riding off-road and so forth, yeah, pay attention to the shock temperature. We've also had customers say, I can't afford a reservoir shock. Can I buy one of these other shocks? If you're going to do that, you're going to have to pay attention to the shock temperature. You're just going to have to spit on your finger and stick it on the shock cylinder every once in a while, and just make sure that you're not cooking the shock, because they do come in here like that. People think they have a warranty situation. We open up the shock, the oil's burnt. It's clearly overheated. It's not a warranty situation. Any shock absorber can take you down some dirt roads to a campsite or a fishing hole or what have you. That's not the issue. The issue is the extended riding. Really what we're talking about is suspension speed. When you leave the pavement, the suspension speed goes up considerably, and your high-speed compression events go up considerably. So if you're going to do that for a short period of time, no problem. We have, inexpensive shocks that are built a little bit more in more of a durable way for off-road riding, that are not terribly expensive, and they'll do that all day long. The issue is when you are on dirt and gravel roads for extended periods of time. You're going to do a BDR, you're going to be what have you.
So what's extended? An hour, a day, a month?
It depends.
What's extended?
It depends on the bike, because it depends on the leverage ratio of the bike. It depends on the spring rate that's on the bike. It depends on how much weight you have on it. It depends on how much the shock is moving and how much it's heating up. If the suspension is doing this, even though you're only doing 20 miles an hour, then it's still doing this, and it's going to heat up.
Okay, so this is the most important question I can ask you. Is there anything I can do to make my shock better, or am I at the top? Do I have the best I can get?
You mean your reservoir shock?
Yes.
Is this the extreme?
It is the extreme.
You've got reservoir, you've got an awesome preloader, you've got a PDS valve, you've got high and low speed compression adjust. Other than setting it up correctly, I don't know what else I would offer you.
That's what matters. We had a great time hanging out with Ted Porter, and I'm hoping you'll learn something about suspension and it's not quite so mysterious anymore. Let me know what your thoughts are in the comments below.